At the Bulldogs game, Chris was given $60 to share equally between himself and his cousins. This graph shows the relationship between N, or the number of cousins who come to the game, and A, the amount of money each cousin will receive. So, for example, if no cousins come to the game, Chris will get to keep the entire $60 to himself. But if one cousin comes, he'll have to split the $60 between the two of them, and he'll have $30 apiece. And same thing would go if another cousin came. We would have 60 divided by 3, and they would each get 20. Well, that's represented here. If one cousin comes, or if it's just him, he'll get to keep the $60. If two cousins come, or one cousin comes between him and himself, they'll each get 30. A total of 3 people will be 20, and so on. So, what is true about the relationship? A, the amount of money each person receives is in direct proportion to the number of cousins at the game. Well, that would mean, if they were in direct proportion, that if one additional cousin came, they would all get the same amount, and so on. A direct relationship would be something more along the lines of a straight line, up or down. The amount each person receives is in inverse proportion to the number of cousins at the game. Now, inverse, what that means is, as one number goes up, another goes down. So in this example, as the number of cousins goes up, the number of dollars each one of those receives goes down. So we might have a winner in choice B. And you might want to take a note that inverse means that as one variable goes up, one goes down. The amount each person receives has a linear relationship to the number of cousins at the game. Well, linear would mean that that you would have a straight line one way or the other. And since we don't have that, we know we can eliminate choice C, because this line is somewhat curved. The amount each person receives has no relationship to the number of cousins coming to the game. Well, we can see a predictable pattern between the number of cousins that go to each game and the amount of money each will receive. So we know that we know D would be incorrect, because it says each person receives has no relationship, and we know that's not true. So it's between A and B. And since we already talked about the fact that an inverse relationship means that as one variable goes up, as in the number of cousins, the number of dollars goes down, the answer is choice B. And finally, draw a box and whisker plot for the following data. Well, in order to do this, we must put the numbers in order from least to greatest. And it looks like 4 is our lowest number. 4, mark it off. Then we have 5. We must first check to see if there are any other 5s. And it looks like there are none. 6 is next. Are there any other 6s? Yeah, we got one more. Are there any other 6s? Looks like we're okay. 7. Are there any other 7s? No. 8. Are there any other 8s? No. Do we have any 9s? No. 10s? Yes, we got one. Are there any other 10s? No, it doesn't look like there are. 11? Any other 11s? We have a 12, another 12, and then finally a 13. Well, to do our box and whisker plot, we need 5 pieces of information. We need the upper extreme, lower extreme, we need the median, need the upper quartile, and the lower quartile. Well, the upper extreme is the highest number, so we have 13. Lower extreme is 4, so we've got that. The median. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. So we need to find the middle number. Well, if we have 11 pieces of information or pieces of data, we know that the median will always be, if we put them in order from least to greatest, for 11, it'll be the sixth number. So we got 1, 2, 3, 4, 5, 6. And our median is 8. And we can tell that because we have the same number, 5, on each side. We have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And all the median is the middle number. Now, to find the upper and lower quartiles, we need to find the median of the first set of the data, which is right here, and the second half. We need to find the median. Well, the middle number of the first half of the data, which will be our lower quartile, will be 6, because that number is in the middle. And again, we have two pieces of information or two sets of data on both sides. So the lower quartile will be 6. Upper quartile, same rule applies. We've got a 12. And we have all the information we need now to draw a box and whisker plot. So let's move this guy on up here a little bit. We're just going to draw a number line. And let's start with about 3. We need to end with about 13 or 14. So we got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, we need to put a little dot where our upper and lower extreme is. So we got a upper extreme, and 4 is our lower extreme. Our median is 8, so we're going to draw a line right here where our median is. Our upper quartile is 12, so we're going to draw a line right here. And our lower quartile is 6, so we're going to draw a line right here. Now we must connect these boxes right here with these lines right here, and then draw a line out to our upper and lower extreme. Now, forgive my artwork here, and sorry, forgive my dog for barking over here. But we also have the upper and lower extreme, upper quartile, lower quartile, and the median. And that is how you draw a box and whisker plot.